Okay everyone, welcome to Natural Language Processing. This is 11411 and also 11611. It doesn't matter which one you registered for. It looks better in your transcript if you registered for 611, but it's the same class. Okay, some of you doing masters require the 611. This is an introductory course to natural language processing. Natural language processing means human languages. So if you're here to learn something more about Java, okay, if you're here to learn something more about Javaese, the language spoken on the island of Java, we actually don't cover that in this course, but that's closer to the things that we'll actually be talking about. My name is Alan W. Black, and I'll be co-teaching this course with David Mortensen, who's down here at the front. We'll mostly be sharing the lectures one-to-one each week, but it doesn't quite work out like that, but it almost does. We have a whole bunch of TAs, you'll get to meet them in general, but we have a bunch of them here because this is the first one. Can you stand up if you're a TA in the course so that people can see who you are? Okay, these are the TAs. You will be interacting with them either electronically or actual face-to-face at the various sessions that we'll be setting up. Okay, thank you. We'll be recording, videoing everything. There is a video section, but most of you can attend. Okay, sometimes you can't attend and you can watch the video. It's not live, but it will be there within half an hour or something at the end of the lecture. There are weekly quizzes that require you to understand, not just watch, but understand the lectures every time. So you will need to watch the lectures in order to be able to answer the quizzes, for which that's part of your grade. What's NLP? NLP is looking at human language, and what we want to do is we want to care about the analysis, mostly the understanding. Okay, we want to understand by computer what natural language is. We use it all the time, but we like computers to be able to have an advantage and understand the things that we're posting online, the questions that we're asking computers. Okay? We also care about generation. We want to be able to generate, machines generate sensible natural language so that we can have dialogues, so the robot, just before it takes over the world, can actually give its appropriate speech and that you can understand why it's taking over the world. Okay? And maybe not exactly that one. Okay? And we also care about acquisition, about how we can learn from the examples that are there so that we can incrementally get better at language. Okay? Let's make this clear. This course is not a linguistics course, but it contains a whole bunch of linguistics. We will be teaching you the techniques that people have been using to understand natural language processed by computers over the last 20, 30 years. And also, this is not a machine learning course, but we will be using machine learning through the course because we're going to use machine learning statistics in order to be able to build models of human language. Sometimes people use NLP to use everything in language technologies. Here at CMU we have an Institute for Language Technologies, LTI, that I'm a professor in, and so is David. We do lots of things in LTI that are beyond what we normally think about in NLP, but in other universities NLP might include speech, it might include non-verbal aspects of facial recognition and hand movement. We believe that is the case. So NLP is a bigger thing sometimes, but here within this class we're primarily talking about text, but we will see a little bit about speech. We'll primarily be talking about English processing, but as we all know, English is not the only language in the world, but we will use that. We're naively assuming that all of you have some competence in English to understand it, and if you don't understand English, please nod now. Thank you. Why do we care about this? Why is this a subject at all? And the answer is, most of the big tech companies in the world now are fundamentally language technologies companies. So Alphabet, which is the owner of Google, Alphabet, which is an orthography for writing Larry Page, who was the CEO but isn't anymore, identified that what Google does and what Alphabet and most of their subsidiaries are doing is trying to understand human language, trying to process human language. They actually care about it. They do NLP as their key form. So Facebook, Amazon, Apple, Baidu, Tencent are all caring about language processing. And so we're teaching you it in order to be able for you to go out there in the real world and get jobs, or to be able to do research in companies or in universities about language processing. Okay? So why do we care about NLP? Here's some subjects that we care about. Obviously answering questions on the web. We're now pretty used to this, that we can type into Google things and we can look things up. You might think it's something to do with database lookup. It's not just that. We have to be able to care when we're making a query of Google, because sometimes there's morphological variants. If we type in plurals, we want it to be able to still match even though there's a plural. And the plurals are not just adding an S at the end. They're sometimes more complex than that. We want to be able to deal when we're keyword looking up things. So we type in Justin Bieber, or if we type in something like why is Justin Bieber so popular? We would like to get an answer that tells us why Justin Bieber is so popular. Okay, because I don't know. Sorry, I'm not supposed to give opinion. Translating documents from one language into another. Many of us here are multilingual. We understand what translation is, and we know it's sort of easy and hard at the same time. We've often been in positions where we've had to understand a document and we don't speak the language, so what do? We go and speak a friend who speaks the language, or we use Google Translate, and you stuff it into Google Translate and you get something that might not be completely correct, but it allows you to be able to make assessments about the document and definitely get something out of it. It's pretty useful, okay, to be able to do that, and that technology is natural language processing, of how to be able to automatically build translation engines from one language to the other using data, usually, and using machine learning, and using things that we'll be talking about within this class. We'll be talking about various aspects of machine translation. How do we do library research? How do we do summarization? Again, we have to be able to look at a document. We have to understand what text is in there. We have to understand what's important, what we can delete to be able to give us the summary of what goes on. So for example, you're too lazy to come to the lectures in NLP. What you'd like to be able to do is take the video. You like to take speech recognition. There's another technology, speech recognition, to get the text out of it. You like to run the automatic summarization, and so that it tells you only the things that David and me tell you that are important. Okay? The things that are on the exam. Okay? If you do that and build a system like that successfully, you'll probably be good enough to pass the course. Okay? But it's probably not a good way to actually learn all the important things about natural language processing, because there's other things we're saying rather than the key features. But it'd still be a very useful thing to do. And you've been in this position, it's like, I've got this document, I have to understand what it is. So what's it about? And you just want an overview of what it's about. And you'd like to be able to do that automatically from the data and find out what's important. For newspaper articles, it's almost always the first paragraph, because that's how newspaper articles are written. For Wikipedia articles, it's almost always the first paragraph, because that's how Wikipedia articles are written. But that's not always the case, that you'll have an abstract of what's actually in the document, especially when you start looking at multiple documents. What about messages? We get messages on different platforms all the time from different people. We'd like to know whether they're important or not. We'd have to look at the content of the message. We have to know who it's from, what it's about. And just because they say the word urgent doesn't mean it's urgent. In fact, I would actually say, I'm not supposed to say this for people that are sending me messages, but if it says the word urgent in it, it almost always is not urgent. At least not urgent to me. I'm rude, you'll now never use the word, but you'll never use the word urgent in messages to me. But urgent doesn't mean that, but other things actually is, you know, your house is on fire, is pretty urgent, okay? And the deadline's been extended, so it won't be next Friday afternoon, it'll be the Friday afterwards. Well, I don't really care about that. But I do care if you're moving it 24 hours from now, because I'm probably caring about. And so I'd like to know which of the messages are genuinely urgent and see which ones I should actually have to deal with now. how to make informed decisions. I have to make decisions about, what job I'm going to take, what courses I'm going to take, and I'd like to be informed about the appropriateness of courses, whether they're interesting to the things that I'm doing, whether they've got dependencies between other courses, whether they're at 8:30 in the morning, because that might make me less likely to take them. So I'd like to be able to use all of this information to be able to give me the right things. And I'd maybe like to even talk about these things interactively. So I actually have my Amazon Alexa and say, Alexa, what courses should I take next semester? And it says, well, what are you actually interested in? And you give your background and they go, well, you could do this and this. And say, well, that sounds hard. My math isn't as good. Should I do something else? Or my math is good. Should I do something else? And I'd like machines to do that. And that means that I have to understand documents and understand what you're saying and understand your preferences. And that's what we'd like to do with natural language processing. Okay. I'd like to follow directions given by a user. So at the moment when you meet a robot in Gates-Hillman complex, which you've probably done, when you meet a robot and you think, how could I get that robot to go and do things for me? Well, the answer is you go to the laptop on the top and you bring up the Python window and you actually program something. Although most of us could do that, why can't we talk to the robot and explain what to do? So you say to the robot, go and get me a coffee. And the robot says, I don't know how to get coffee. So you say, well, you go down the ramp to the bottom and you go to the front and you ask for a coffee and then you wait for your name to be called. You then get your coffee and then you come back up and then you give the coffee to me. So you explain all these things in natural language and you'd like the robot to be able to do it. But at the moment you have to hand program it, which is fine, but it would be better if we could actually say, by speech, how to do that. Fix your spelling and grammar, okay? Some of us are non-native, and some of us are native and not very good at writing. It would be good if we actually could have something that's watching us, correct the spelling. Well, mostly it already does that. Correct the grammar, or correct the register, the way we are actually writing things. That would be very useful to be able to do that. That's not appropriate for a term paper. That's not appropriate in sending a message to a professor. That's not appropriate for sending a message to a friend. Okay, how can you actually know when that's appropriate or not? And how do you do it in other languages? Okay, it's fine, there's buckets of data for English, but what happens if we want to do it for languages that we don't have much data? This is something that me and David would like. We'd like to automatically grade exams so that we take the exam and then we look at it. And there are things that will do that. But, clearly multiple choice is pretty easy, but when it's essay things, if you want to look at it on essays and diagrams, you would like to be able to work out how to be able to grade exams and give a fair grade to everybody in the course by looking at how it's actually written. This is something that people do. Many of you have probably done things like TOEFL and SAT. There's an organization in the US called the ETS, where they actually automatically grade most of their essays by a machine, but also by a human. And if they agree, they use that grade. If the machine and the human doesn't agree, they go in and get another human to actually grade it so that they can find out what's right. Because it doesn't always work, but it often will work. What about more creative things? Poetry, novels. Can we get a machine to generate something that's genuinely new? Why would we want to do that? Humans can do that. Yeah, humans can do that. But the idea of being able to give a story that actually is interesting and engaging would be a useful thing if we could get our machines to actually do this. When would we like to do this? Well, this isn't just for, Pixar when they're doing the latest movie. It could be that, we have all these online massively multiplayer video games. It might be good if we could generate quests that are appropriate and interesting and at the right level of interest and have the right mix for the people who are going to take part in it, and generate an interesting sub-story that allows people to follow and that they find good and has the right twists in it and has the right background in it. And so this would be a useful thing to do. We're not there yet. There are people working on storytelling. I have a number of PhD students who are working on storytelling, on trying to take information and generate a narrative which will give you the information in the way that's appropriate for you to understand it. Okay? Listen and give advice. And that's not just saying, that's really interesting, okay? So that works surprisingly well. But you'd like to actually actively take the information that's there and say, no, you should take a job in California. It's the best place on the planet. It's got the most wonderful weather on the planet. Or, no, you should not take a job in California because the amount of money you get paid will nowhere allow you to be able to live in a reasonable sized cardboard box. And you actually will want to live somewhere where you're going to get, a cardboard box with multiple sub-partitions in it that you might be able to get in Seattle instead. Okay? So you'd like to be able to have this conversation that is informed and that has information about if it's where to live, jobs, cost of living, what it's like to live in the place, what the weather is like, what the community is like, what schools are like if you're caring about kids through school, what the other job opportunities are. You don't want to move somewhere and then get fired the next day, so you want to find some other job. And so it would be good if you could do these things. Estimate public opinion. Okay, so we have an election coming up in the US this year, and it will be a lot of fun. There'll be a substantial amount of NLP processing in order to influence people in the elections. I teach another course in computational ethics where we actually explicitly talk about that. I'd like to point out in that course there are no homeworks that involve influencing the US elections. We don't do that as homeworks, we just do that with European countries and Brexit. But we don't do that. But how do we know when we look at this massive amount of Twitter, most of which is utterly useless, to know what public opinion is? Do we know about what people think about fires in Australia, or what people think about, Meghan and Harry actually leaving the United Kingdom and going to live in a better country? Wait, I'm not supposed to say that, right? Or how do we know what people think about the latest movie that came out, or what they think about the Oscar list that came out this week? How do we look at people's opinion on that? And it's not just counting about the number of thumbs up and thumbs down. People are much more subtle, and you don't just want to know whether people think it's good or bad. You want to know why. Okay? If you release a product, you'd like to know what people are criticizing about it, so you can do something about it, or what people like about your product, so you can continually advertise it. So you'd like to know that, and it's not just a matter of counting the words. You want to know how people talk about it, and it requires a level of understanding. Okay? What about reading everything and making predictions? Okay, for the whole world is just too hard, but there's a number of cases where that's not utterly ridiculous. Can you take all the papers at the recent conference and predict what's going to happen next? And the answer is, humans sort of do that. Experts in the field sort of look at that and go, well, there's a trend that's happening. Maybe I should try and work in that way. Or can I do something like look at all the new Wikipedia entries that are being edited at the moment and try to find out where people's interests actually are, and then find out something that you might actually care about. Okay? Do people care about quantum computing? Do people care about transport? Do people care about something? Because you look at where people's interests actually are. Okay? Interactively help people learn. We've tried to do this a number of times. You build actually automatic tutors, and these tutors watch what you do, and they work out what you know and what you don't know. And imagine if you had this intelligent tutor that was sitting on your shoulder while you're actually doing things that would remind you things and would correct you when you're wrong, or point you at the things that you didn't know that you didn't know, or remind you about the things that you do know so you feel better about yourself so you can try something harder. Okay? A good human tutor can do that, can actually lead you through things and make you learn things that are new, and that involves understanding language, understanding the material being taught, understanding how humans learn, and much more important, how you learn, so that you can actually customize itself to your learning capabilities. Do you prefer diagrams? Do you prefer videos? Do you prefer text? Do you prefer all three? Do you prefer some combination? Do you prefer something else? Do you prefer ways of remembering things that are by being interrupted? Because this is sometimes true. that people can learn external things. How do we help disabled people? What I always say about this, most people go, but I'm not disabled. And the answer is, well, actually, you're not disabled yet. You're all going to get old, okay? And once you get old, your eyesight fails, and you can't remember things, and you like to be reminded of things, you like to be told things. I'd really like something, a little camera out my glasses that basically will tell me the name of the student who's standing in front of me, who's asking a question that I'm supposed to remember, and I'm going, hang on, I'll get it in a minute. I need some context to be able to do that. Or I'd like something that does translation for me, that I am standing in the middle of Beijing, and I have to be able to read signs and be able to communicate with local people. And in spite of living in a community where 50% of the people speak Mandarin, the ones here all seem to speak English, but that's not true when you're standing in the middle of Beijing. Not everybody, anyway. And so I'd like language services that are basically telling me, so I'm sort of disabled in the fact that I can't speak Chinese, at least not very well. Help refugees and disaster victims. One of the things that we've done in the recent DARPA project is, imagine there's some natural disaster that happens, an earthquake, okay, and it happens in the region where nobody knows the local language. How can you actually go in and start understanding the social media, the news, to know what to do to help? Because it's like all this stuff is in Thai, and I don't understand Thai. How can I actually work out where the disaster is affected most, where the transport is affected, where there's bridges down because there's a flood, where people need medical attention, when I don't speak the language, but it's all there in the Twitter feed, but I don't understand it. And okay, so Thai's not so bad because we have lots of Thai speakers, we have Thai speakers in the room. But it might be some other language, or it might not even be a language you know, or I don't know what this language is. It's got funny squiggles in it, and I can't even read what it is. You often can work out what it is, and if you don't know, there are techniques. Type it into Google and see which language code you end up with. But I'd like to be able to understand that language, extract the names of the places and people that are in there, who's affected by what, where things are, so that I can actually go and help. And this is something that we actually do, especially in languages that we have no information for. We also care about indigenous languages. Local languages often are disappearing. Can we document them? Can we build some representation of them to be able to give access to the information world? It is not the case that everybody in the world speaks English, some European language, in Putonghua. There are other languages on the planet, and we'd like to be able to give access to everybody, and we'd like our technologies to be able to work. So, careers, okay? NLP is a pretty big technology at the moment. The industry is definitely caring about it in a big way, both educational technology, but also, Facebook does an awful lot of NLP because they want to analyze, well, where to put ads, but they also want to be able to know what's going on to follow trends, okay? Government cares about it because government has to communicate with their people, and their people speak different languages. Sometimes they may be in a country where there is one major language, but not everybody speaks that language. In the US, there is only one big language, that's English, but actually there's a substantial number of Spanish and Chinese speakers, but there's another hundreds of other languages that are spoken in North America, and the government has to communicate with them at times, tell them what to do in case of disaster, tell them what to do when they've committed a crime, tell them how to fill in their taxes, tell them how to learn about education. So you want to be able to communicate, you want to understand what's actually going on, okay? Academia, we've been doing this for years, and I don't think it's going to go away because we're trying to learn more and more about how to work with languages and be able to educate people to be able to deal with all of the languages on the planet. Humanitarian organizations actually care about it because they're often working with indigenous low-resource languages, and how can we communicate with people when you don't have a common language? How can you build technology that will help? people who are not literate to be able to use the web. What happens if you don't have any language to type the keyword in? Well, you could speak the keyword. So imagine that what you do is instead of typing in Justin Bieber into YouTube, what you could say is Justin Bieber, and you get all the videos of Justin Bieber. Now, that's probably not required for Justin Bieber because there's so many of them, but it probably is required if you want to get farming information, if you want to get health information, and you can't type anything in. It would be useful if you could actually do that. Or, of course, cat pictures as well, because that's what you need the web for. It's not just about money, okay? It's about ethics. One of the things that we're trying to do here and educate you at CMU is to learn the consequences of the things that you are actually doing when you're building technology. And so, as the things that you're doing actually helping humanity, so if you build something that allows to do better advertisements, and assuming advertisements are thought to be a good thing, they help people sell products, they help people make money, that technology is equally good and appropriate for giving misinformation in elections, okay? And it's a bad thing. You want people to be well informed in order to be able to make decisions about voting for their politicians. So maybe we can use technology to be able to inform people when they're getting fake news, when they're being influenced. You are being influenced at the moment. This is propaganda. Of course, the message itself, it's telling you it's propaganda as well, but knowing that makes a difference, okay? And so we do care about how this technology is used, not just blindly building it, and so be aware of it. Okay, you can work for the government. Sorry. Okay, you can work for the government, okay? Wrong slide. Sorry, when I'm presenting. So you work for the government. Now, some people think the government is, Darth Vader, and some people think it's the Jedi Knights. And the answer is a bit of both, and there's always a bit of both. Okay, governments actually genuinely are trying to improve people's lives. Now, they might be genuinely trying to improve people's lives so that they pay more taxes. Okay, so there might be sort of underlying evil, but they're genuinely trying to improve people's lives. And that's hard. It involves communication. It involves getting information out and knowing that that information is getting out. And also understanding the information that's coming back. Okay? So you have a website and say, we'll take comments on your on this new law that we have, and you get 16 billion comments. How do you know what people said? How do you know the bots from the actual information? How can you summarize it in such a way that's useful to be able to do something about it? You can't read it all. You can't go and get people to read it all. You have to do some sort of analysis. And that's where NLP becomes important. And there are lots of aspects of governmental use of NLP. Not just the US government, there are governments in other countries as well. Okay? So I'm going to go into a little bit more detail about some of the linguistic aspects, and not just its usage, but the linguistic aspect that we're going to cover over all of this course. Linguistics has been studied for approximately 5,000 years, because one of the things about the linguists is they usually write down what they're doing, okay, because they're interested in linguistics. So we have pretty good records for about 5,000 years, but we've probably been doing it for longer than that. Linguistics as a computational field has been around for 60, 70 years, and we're quite good at getting some level of modeling, but it's only really in the last 20 years we've got to the level where we are actually applying it for the general person, through Google being quite a good example. Okay. Starting from the bottom, okay, we can actually say these two things about speech and text. They're sort of the same thing, but not really, in that there are ways to be able to, they're linear representations of what people are trying to communicate about, okay? We're all familiar with text, although text is a relatively new technology. It's only a few thousand years old, okay, while speech has been around for a lot longer than that. However, nowadays, most of the information that we can get access to is text, though it is still the case that people talk more than they type. I know you think you send an awful lot of messages on your phone, but actually you're still talking more than you're typing. This course is going to primarily look at text, look at words, and look at that aspect. rather than speech. We'll have a couple of lectures on speech, but we have other courses that deal with speech. Okay? So we are going to care about orthography, how things are actually written. We use the Latin alphabet with some extra characters for English, but in other languages we use somewhat benign. There's a somewhat limited number of writing systems in the world compared to the number of languages, and all of the writing systems that we use are deeply inappropriate for the language that we're actually dealing with, apart from Korean. Okay, well done, Korean. But we use the Latin alphabet. Latin was a language spoken by the Romans 2,000 years ago to write this Germanic language where we've got this completely incomprehensible spelling thing. I know you all know that whether you're native or not, that the spelling in English is just random. It's not random. If you know when the word came in the language and which language it came in from, it's very easy to do spelling. Yeah, sure, I'm going to use that for the last 1,000 years of whether it's Germanic or whether it's Norman French, etc. And whether you know that. We're going to talk about morphology. Morphology is the modification of words that actually happen in some similar but slightly different grammatical form. In English, it's relatively simple compared to other languages. We have plurals and singulars, so we put an S or something else, sometimes an ES or something else in order to be able to indicate that it's plural. We have past tense, we have some derivational things that are productive. We put ing on the end. In some other languages, it's much, much, much more complex than that, okay? And in some other languages, much, much, much more simpler than that. Chinese is one of the simplest form of morphology, but it exists in almost all languages, and if you don't deal with it properly, well, your keyword matching doesn't work, because now you get, you know, I wanted to look up, I wanted to get pictures of cats, and I typed in cat picture, but it's been labelled as cat's picture, and therefore it doesn't match, because it's got different letters in it. And so how can you actually deal with it? These are really the same thing. Further off from that, we have to care about the words. These words mean something. Sometimes it's not always clear, sometimes it's very clear. We want to be able to match between them. We'd like to be able to know when words are similar. We want to know that the word tall and height are somewhat related. And we'd like to know that a bunch of words are all about colour. They're different colours, but they're all about colour, so they're talking about some property of something. And we'd like to know some relationship between those, and we'll talk about that. We're talking about syntax. So above that, we deal with syntax, and that is the structure of the words, how they go together. Some people think that syntax isn't important, but it really is. If you want to know what's going on in the sentence, you really need to understand the sentence about who's doing what to whom. If you don't have that information, you might get it wrong. Okay? You can't just assume it's a bag of words. There actually is structure, and sometimes it makes a really big difference. We'll talk about how to automatically find that structure, how to automatically parse a sentence to get that hierarchical structure and know what the noun phrases actually are, know what the verbs are, and know what the relationships are between them. Higher up, we'll talk about the semantics of the words. What do they actually mean? Okay, so we can do comparisons in the meaning domain, because although all these colours are all colours, they mean something different. And sometimes they mean more than just the colour themselves. Sort of red can mean stop and green can mean go in many circumstances, not just traffic lights. And so you'd like to be able to have some representation of dealing with that. As you go higher up, you get pragmatics. And what you discover quickly about human language is we almost never use it literally. So we're not actually full of sentences that says the pen is on the table like we might get in a linguistic textbook. We get these complex other things that people say that mean something that are not immediately obvious. When I say to my Amazon Alexa, do I need an umbrella? Okay, I'm not actually asking whether I need an umbrella or not. I'm asking if it's going to rain. I'm actually asking about the weather, even though the actual question is about whether I physically should have an umbrella or not. Okay? But the purpose of that question is really, in order to answer it, the machine has to know about weather and all of it. But that's not obvious if you look at the literal meaning of that sentence. Then when we get higher up, we get notions of discourse. So this is interaction over multiple turns that are actually happening in, say, a dialogue system. So when I'm arguing with my robot that it should not blow up the world, okay, I'm forming this argument about putting forward hypotheses, giving definitions of things, trying to justify to this robot that it shouldn't actually press the button and blow us all up, okay? And of course the robot might be trying to do the same thing back again, okay, and maybe it convinces me, but unlikely, not yet anyway. Both times I've argued with the robot. No, I haven't actually done that. But this argument that happens when you're, not necessarily an argument, this conversation, okay, about how to achieve something, humans are really good at, okay? They're very good at being able to talk to somebody, to get a piece of information, to get something to do, to find out directions, to understand how to do something. But machines are pretty bad at that. And that's something that we'd like to be able to do. So why is this hard? Okay, the answer is, well, human language is a little bit wishy-washy. It's got a lot of ambiguity in it. There's not only one interpretation. People use language in a rather loose way, so sometimes it's confusable, even with humans. There is lots of variation that's completely allowed. When we're speaking, it's quite common that we'll do false starts. So I'll say something where I've said so I'll say something, and most of you will just tune that out. You don't hear me actually doing it, but the machine's stupid and it says, well, so I'll, I can't parse that, so it fails miserably. These mappings between syntax and semantics, pragmatics, etc., can be arbitrarily complex, and being able to get appropriate training data, if we're going to take a machine learning view, is almost impossible. What's more, when you build a machine that's based on some amount of data and you actually interact with it, the capability of the machine will affect the conversation. So in other words, people will adapt to the machine, and therefore they'll start doing things that they didn't do in the training data because they're now talking to a machine. And so that can get very hard to be able to deal with things as well. Now, how much processing you need to do really fundamentally depends on the task that you're doing. That aspect's going to come up again and again during this course. It's like, yeah, getting a full first-order predicate logic representation of the sentence is incredibly hard, but there's an awful lot of things that you don't need to do that for, so you don't need to care. Or when you do need to do it, you're in such a constrained domain that it's very easy to do. So the appropriateness of the tools and techniques that we're going to talk about are really dependent on the particular task that you're doing. And you should always remember that, because we're going to tell you multiple ways to do things, and you're going to ask us, so which one should I do? And the answer is the one that works best for you. Okay? Because if it works better, it's better. Okay? So you have to be able to test things, and you have to be able to evaluate things, which can be difficult. I talked about some of these things. Ambiguity is incredibly common in language. We basically, if you think about it, it's not that everything we say has one and only one meaning. In fact, that's relatively rare. What happens in communication is there's person one and person two, and actually really the universe all around about it. And person one says something in 7 seconds. It's about the average length of an utterance. 7 seconds by blowing wind through their vocal tract. And the other person's supposed to completely understand what that person is communicating. No, that's really hard. So there's a whole bunch of assumptions that we have when we're actually saying things, and some are explicit, some are implicit within the environment that we're in, some are implicit with respect to the culture that we're in, some are implicit about the particular task that we're doing. When we say it can mean lots of different things depending on the context that we're actually in. Also, for any particular thing, there are multiple ways to say it. So it's not just that one thing means many, it's there are many ways to say the same thing. That's something that makes language interesting. And we really do genuinely do things in a different way. So just because one person orders pizza with one particular set of words, somebody else might order the same pizza in a very different way. and we have to be able to interpret those such that they get the same pizza. Well, okay, not the same pizza, because they should get pizza 1 and this should get pizza 2, because it's pretty annoying. It's like, here's the pizza, but by the way, I've got to deliver it to Fred as well. Different languages have got different ways on how to do that, and there are different aspects of it. So if we take Japanese as an extreme, Japanese typically doesn't use pronouns, okay, so this is she, it, or even proper names when they're communicating. And the way you understand what's going on is really something to do with context and maybe something to do with politeness. If I'm going to ask you if you've read a book, I would not say, have you read a book? I would say, read book, polite, okay, and the hono yomimasu ka, and I would expect people to understand that I'm talking about them, okay. Well, I was saying that if I read the book, I would say hono yomimasu, me read it, and I don't say me, I just say book, read, okay. Because if I said I read the book, it would be this contrastive thing as if somebody else had read the book. Okay, and people go, well, why are you mentioning yourself? Clearly the context would allow. While in English we use pronouns all the time, Chinese we use pronouns, but different languages have different uses. We have politeness, as I mentioned, across different languages, and these things affect how we actually interpret things. We'll be talking about those too. We study models. Again, one slide. Models. We study models, okay? And models are representations of the real world, okay? There are a bunch of random floating point numbers. They're maybe not random, okay? But they're basically some representation of the real world. And the reason we have models is from these models we'd like to be able to do predictions. So given that representation, I'd like to be able to predict what happens next. So given this model and I get some sentence that's said by somebody, okay, I would like to interpret it to know it's a large pizza with pepperoni or they want a Coke, okay? So I need to know what these bunch of random words that the person said to be able to predict what actually should happen, the event that should happen given those bunch of words. So I can train that from data, I can evaluate it, I can update it depending on how people order pizza or order Coke. But I'd like to have this model, this probabilistic machine learned. It might be rule driven, okay, but if it works, that's fine. It might be rule driven with some weights on it. It might, whatever it is, it's going to be a model of the world that it can do predictions about when it sees examples in the world. So we call these models, okay. Again, this aspect of you do the thing that actually works, and sometimes really simple things work. Okay, so for example, I said I want you to build a model that tells me whether the sentence is a question or not. Oh, let me ask you, okay? So imagine you had to write a program to tell me whether any given sentence is a question or not, okay? Give me a very simple way to do that.
Look for a question mark.
Look for a question mark, okay? Now, of course, that's not always going to work, but if there is a question mark, it's almost certainly going to be a question, okay? Unless, of course, it's a statement. Questions often end in question mark, okay? But in general, that's a really good way to do it. But people don't always put question marks at the end of things. So that might do it. Can somebody give me something else? It's simple. So the grammar of the sentence might be able to do it as well. Anything else?
The last word.
The last word. There'll be a ma at the end of the sentence. Exactly, okay?
Yes, no questions, but not
For yes, no
questions.
questions. Yes. I'm sorry, but in Japanese it's a car. Yes, in some languages they've got an actual verbal question mark, which makes your life much easier. Although even then they don't always do it. At least in Japanese, you can ask questions without actually putting the car at the end, at least in casual speech. Anything else? So there's a bunch of question words, like who, what, why, where, okay, that actually if they're there, it could be a question. It doesn't guarantee, but it could be a question. So these very simple things actually can help quite quickly get you to doing that. And yeah, you can train more, okay, and you'll get a little bit better, but that will get you probably 80-90% correct. Okay? And it also depends on the data. If you're talking about newspaper questions, then the question mark will get it, because they almost always have to do that. So we are talking about computational things, so we are talking about programs. Okay, so what we actually want to do is get a representation that we want to be able to run code on, that we can actually test the results to see whether it's better. Okay, so we're not just talking about the theoretical things, although we will talk about the theoretical things because it often influences the things you're trying to do in a computational way. Okay, so we will be talking about formalisms, we will be talking about different ways to represent words, different ways to represent syntax, and we're also talking about algorithms as a way to be able to get that information, to find out what the part of speech is, whether it's a noun or a verb, how to be able to do parsing, to be able to get the structure out of it, how to do morphology, etc. So applications change all the time. So it used to be that things were very hard in natural language, and being able to deal with a very small fixed number of sentences was considered to be cool. That's not true anymore. We're usually wanting to deal with hundreds of thousands, if not millions of sentences, and be able to estimate how well we're actually doing it. But we still want to run on data and find out how good or bad things actually are. But these things change over time, and things in natural language, because it's a really hot topic at the moment, change during the semester. The latest, hottest technique that was shown at Europe's last December will not be by the end of this semester, and so we'll update and try and tell you about these new interesting things that are actually happening. Also, the big companies are spending a lot of money in being able to do things better, and they make big announcements, sometimes over-the-top announcements, about how well they're doing with language, how they've improved translation, how they've improved natural language understanding, how they've done better dialogue systems. And so their claims will be out there, but don't worry, it won't get solved. Okay? There'll still be non-trivial problems that will be fundamentally based on the things that we're actually teaching you in this course. Oops, it shouldn't say 2019, it should say 2020. We should update everything that's deeply important this year, not that we know what's going to happen yet. So computational linguistics is not about, I would like to distinguish that from natural language processing. Computational linguistics is caring about the linguistic aspect, but doing it in a computational form. We borrow from that, we sometimes merge that, but there's a different field of computational linguistics where they're looking at the linguistic aspect. So what is the space of possible things that humans can actually do, and modeling that space, rather than saying, I'm going to solve my particular question answering problem that we're doing in NLP. These things use the same information when we're talking, okay, when we're learning how to do this, but they have different goals. Okay? At a computational linguistics conference, saying, look at my wonderful score I got on my question answer test set, is not as interesting as what it is at a NLP. Information extraction is still there. We have an awful lot of data that's just text, because that's what people write. This could be Wikipedia. This could be reports from doctors about patients. It's written in text. It's not written in some formal representation. Detail about manuals or fixing cars or fixing planes. How do you extract that information to be able to compare across things, to be able to deal with question answering, and this is called information extraction. This is assuming it's in English. This is assuming that it's typed rather than handwritten, which would also be hard. Question answering is something that we're still getting better at. People think it's really good that I can ask Amazon Alexa what the capital of France is, okay, and it'll tell me, it gets it right, it's pretty cool. But the capital of France is like, it's a fairly static thing. It doesn't change very often, okay? So it's been Paris for at least as long as I've been alive. Though Germany, however, has changed its capital since I've been alive. But these are static things. But what about things like, what's the time of the next bus to Squirrel Hill? That doesn't have a single answer. It depends on the time you ask it, okay? Or other things that are a little bit more to do with opinion, okay? What do I do with my pregnant cat? That's not going to be in Wikipedia, Okay? Well, it might sort of be in Wikipedia, but it won't really be in Wikipedia. Somewhere else will have that information. Okay? Why is Justin Bieber popular? Okay? It's not going to be in Wikipedia because they keep removing it every time I add that information. I don't really. So we're still interested in it. And chatbots pretty much suck at the moment. Okay? Everybody's trying to build that technology. Everybody's trying to make it so that you can interact with a bot rather than a human. But it's really a bunch of template fixing, and anything more than that really doesn't work. Okay? It breaks too often. Okay? Hands up if you know what its English translation is shao ice. It means small ice in Chinese. It's a bot that sits on WeChat, Xiaobin. Yeah. Hands up if you've ever used it. No, people won't admit to. Oh, people do admit to using it. Okay, so it's this bot with a personality of a 16-year-old girl that chats to you in WeChat. WeChat is sort of Twitter in China. It answers questions. It's based and trained on Microsoft Forum communication. It's quite cool, okay, but it doesn't really understand anything you do, and it mostly is just about chat, unspecified. You ask things like, you know, my girlfriend won't call me back, what should I do? And it'll give you an answer. I don't recommend what she recommends you to do. It doesn't work. But she'll give you an answer that's in domain. Okay, and that's pretty cool, but it's very superficial. In fact, for all the wrong reasons, the reason that they say that the personality is a 16-year-old girl is because they believe that 16-year-old girls can't concentrate on anything and will change subject all the time. And so their lack of capability of actually representing context well, they then blame on some made-up aspect of modeling teenagers. But it's fun. Machine translation, we've always liked to be able to do that, and some of the earliest work in NLP is being able to translate from one language to another. We're pretty good at it now, okay? But we're still not there, okay? For the most part, for major languages, you can get translations across to other major languages with a level that you can usually work out what's going on. But it wouldn't be good enough to publish, okay? It wouldn't be good enough to put in a newspaper, and it probably wouldn't be good enough to actually use as in an ad if you're trying to show off. We are being recorded, aren't we? Anyway, I'll say this. So MATLAB, you might be aware that MATLAB is this online computational system. For a while, had a bunch of ads where they were trying to show off that they were really good at other languages, and they had a Japanese ad that was just written in Japanese and everything else was in English because it was trying to pretend that they knew Japanese. But it was so obvious to any Japanese speaker that the Japanese statement had been translated automatically rather than by a human because it said anatawa. Anatawa translates as something like you, second person singular, but you would never say that in an article. It's just not appropriate to ever use the pronoun, okay? And it means something much more like, you know, dearest or darling than actually you. And so it's like, you get this ad for this geeky programming language with math in it, and it starts off darling at the beginning of it. What? Anyway, yeah, okay. So you have to be careful about it, but you get the meaning sort of out of it. Anyway, that's pretty good, but we're still not there, and we're very good at Wikipedia type newspaper things, but we're very bad at Twitter, Weibo type things because there's less information in the sentence and much more in the context, and we don't do that very well. Summarization. We still would like to be able to do that. We really like to know what's going on, both from masses of documents or masses of tweets, or just, oh my God, I have to read this whole book and give a report by tomorrow. Can it just give me a summary? Well, often there already is one, but we'd like to be able to do that. Opinion and sentiment analysis is definitely big. Everybody wants to be able to do that. You want to know what people think, and importantly, why do they think that? So you want to look at not just whether they like or dislike the movie, you want to know what they liked or disliked within the movie. Was it the characters? Was it the music? Was it the direction? Or was it that it had a baby Yoda in it and that made it actually acceptable? Social media analysis, there's an awful lot of stuff online nowadays, and everybody would like to know what it means, including me. So I want to keep up the trends so that when I'm talking to you about examples, that I don't just keep using Justin Bieber, well, half of you are going, who the hell is Justin Bieber? Was that somebody from the 1950s or something? No, okay, but it was some time ago. So you want to know what's going on, okay? And you like a summary rather than have to read everything because it's a lot of work to read everything. Fake news, you're probably very much aware that people are putting out fake news, just things that are false, okay? Man didn't walk on the moon, that's just false, okay? But it's not just the false things, it's the things that are misleading, okay, that you'd like to be able to capture as well. And so being able to know what you're reading is being targeted to you and where it's being targeted to you would be a very useful thing to be told. And it's quite hard to do, okay? But it's something that we'd really like to do. Facebook's panicking to try to do this, to make sure that they do or do not influence the upcoming election, because if they don't do anything, they will influence it. Anyway, okay. And so these are interesting problems, these interesting times that we live in, and the technologies that we've built over the last 20 years are genuinely affecting everybody's lives. So we have to care about that, okay? And so propaganda, so-called micro-targeting, where we actually take a particular targeted message to David here to actually influence him in his voting record, okay? Actually, it's pretty hard to change people's voting to a different party, but it's very easy to make them vote or not vote. So if I want the Republicans to win, okay, what I say to all the Republicans at the time of the election, actually 24 hours before the election, I say, oh my God, you're so close, but in the polls the Republicans are not ahead. So only if everybody votes will the Republicans win, okay? And in making the Republicans win, I then say to the Democrats, yay, you've done it. You're way ahead in the polls. Everything's gone really well, and congratulations, it's definitely clear who's going to win. And all the Democrats who were going to vote but weren't very sure were going, it doesn't matter, don't need to vote. Okay? And while the Republicans are going, I'm not going to win, and so they go out and vote. So slightly more people in the Republicans vote than I'm not really picking that you're the Republicans. So you guys are on the right and you guys are on the left. But, yeah. So you can actually encourage or discourage a margin to change, and it's surprisingly easy to do that. And, well, we know what happened in 2016. Not that I'm teaching you how to do that. Okay. So we're talking about human language. What about brains? Are we actually going to stick pins in people's brains and actually work out what they're thinking? And the answer is, yes, we do that at CMU, but not in this class. Okay? So if you're wanting to stick pins in people's brains, I'm sorry, you're going to have to do a different class. Okay? And this is, again, this distinction between NLP and computational linguistics. Computational linguistics cares about humans, how humans process language. So if we find an algorithm that works and gives us a good solution, a linguist can validly say, but that's not how humans do it, okay? And that's valid because you're trying to model what humans are doing, okay? And the limitations that humans have, which we do have lots of. But if we're just trying to get a better score or build a better computational system, it's valid to do things not the same way as humans. Computers are not the same as humans. And that's a perfectly reasonable thing to do. But it's good to keep these things distinct. Okay. So NLP is sort of focused on the technology end of it, and computational linguistics is really on the linguistics, maybe AI or cognitive science. That's not to say they're completely separate. They do overlap a bit, and it's often useful to know what the other people are doing because you can learn things from it. A number of things in the very hardcore technology part are people who are then saying, well, Is it learning linguistics? Are word embeddings actually learning something about real, true meaning? And there's been experiments on that, and they're very interesting. We've mostly done these. Be aware that, so I should probably say, for those of you who've been at CMU for some time, you can probably read this. If those of you who are relatively new at CMU, don't worry, you'll be fluent in Chinese soon. This is Chinese, okay? Although, rather interestingly, this is from Taiwan. Is it? Is this simplified or traditional?
It's traditional, but it has some simplified characters.
Okay, so it's from Hong Kong. A number of, so for those of you who don't speak Chinese, and that's actually fine, because that's why we've got machines to be able to understand Chinese. There's no word boundaries. Okay, so we can't actually find the words. Well, that's not true. People always think that's really weird if you come from one of the European languages or one of the Indian subcontinent languages where we put spaces between words. And the definition of words is not as clear as what everybody thinks they are. In English, for example, is Los Angeles one word or two words? Yeah, two, one. It depends. What you're using it for. Sometimes you want to treat it as one word, and sometimes you want to treat it as two. Okay? When we speak, we don't put spaces between each word. And yet we can perfectly parse things into words without actually having a written form. So words with spaces between it is a relatively late thing in our language. So, Chinese is not the only language not to put spaces in it. Thai and Japanese are two of the other major ones that don't do it. So you have to somehow segment these into different forms. And how people do it have different definitions, but they're relatively consistent. And much more importantly, they should be consistent always with the things that they're actually doing. This is something about the getting tickets for the Para-Olympics, I believe. So we have to care about what the words are, so we have to discover what the words are, we might have to define what the words are, and that can be harder than what you think it is. It seems easy, it's where the spaces are, but there are other weird things that go on because we might put a number with km after it, but we really want to separate these out into the number and the kilometre form. Apostrophe S, is that part of the word or not? The answer is, it is not part of the word. Okay, that's one of these things that's unquestionably true, even though people disagree with me, but they're wrong. But for language processing, you really want to separate the apostrophe S off at the end.
Linguists say you should separate the apostrophe S as well. So
yes, it's for most processing, you want to get rid of the apostrophe S because it's not really attached to the previous noun; it's attached to the previous noun phrase, or at least nominal, and when you're looking up words, you really want to keep them separate. It's just much easier to do that. Syntax is really interesting. So it tells you what's going on, okay? And it tells you what the relationships between the verbs and the main nouns actually are, and the nouns and any subordinate clauses that are in there. If you don't have that, you just get a bag of words, and it's a mess. It's sort of, you can deal with bag of words if you've got very short sentences, because it doesn't sort of matter. But as soon as you get anything of any complex sentence, if you don't know what these words actually join together, then you're not going to understand what's going on. Okay? So, and some things are right, and some things are wrong, and some things are, I don't know, and some things are completely understandable but wrong. Okay? I want to fly to Tokyo, I want to fly to Tokyo, they mean the same thing. I found a flight to Tokyo, it doesn't quite mean the same thing, but maybe, okay, well, I found to fly to Tokyo, it's like, wait, what? No, but it's sort of understandable, okay? And somebody might say something, okay? Let's look at some simple examples of ambiguity. Students hate annoying professors, okay? There are two standard meanings of that sentence. Would somebody like to explain one of those meanings?
Students don't like bothering professors.
Yeah, so they don't like asking them the same question, will this be an exam, will this be an exam, will this be an exam, will this be an exam all the time. But there's another reading for that, which is...
Students don't like professors that are annoying.
Yes, professors that are annoying, okay? And so that's like the professor keeps saying, don't ask me that question, don't ask me that question, don't ask me that question, okay? So, and it's completely ambiguous. It depends on the context, okay? It has both meanings, or maybe either meaning. It's not clear whether it's some superpositional quantum state that can be either depending on the context it's in, or depends on the actual application that you're doing, and it depends on the conversation that you're actually in. And so we have to care about this. So sometimes semantics is very easy. If I'm building a language that I want to communicate to a robot, and I'm going to tell the robot to move forward 5 meters, go back 5 meters, go downstairs and get me a coffee, these are very, very clear. The semantics of these sentences are actual physical actions of the robot, okay? And so it's pretty good. And you can evaluate whether it works, and you find the different ways to actually say it. And that's good. Many dialogue systems are in exactly that position, okay? So you can call up the system and you say, when's the next bus from CMU to the airport? And it'll tell you, okay? Well, if you ask that system, do you like traveling on the bus? Almost certainly it will not be able to answer that question, okay? Because it only deals with very concrete semantic things. Humans, however, deal with much more wishy-washy things all the time, okay? And that's something that we should be aware of when we're actually trying to care about semantics. If we're in a domain that we're only caring about bus times or airline times, it's pretty easy to come up with the semantics. If we're dealing with things that are to do with opinions, it's pretty hard, okay? We'll come back to some of these other ones. Pragmatics, as I said, do I need an umbrella? Okay, is it going to rain? At least that's the way you would operationalize that in giving an answer if you were trying to write a piece of code. That actually was an example that somebody at Amazon gave me. What we were doing was they were looking at people asking Alexa questions, and they were finding out every time they fail and finding out what the next sentence actually was. And what they did was they looked for the most common things that were said and failed, and then something afterwards that was right, that they could deal with. And do I need an umbrella was a very common thing that people would actually say, that the developers never thought that people would say, but they discovered that that sentence was often followed by, after Alexa says, what? Will it rain? And so they worked out, oh, it probably means, and it does mean that, but they never thought about it, so they learned from the data. Which is okay. That's the overview, okay. I'm now going to talk a little bit more about administration type things. We have a web page. It's really important you get access to the web page. You should have access to the web page already. We'll have links to the slides, links to the homeworks, links to the videos that are coming, so you can actually find out what's going on. Okay? There is a book for this course. This book is really, really useful. David and me will remind you all the time that you should read the book, okay? And you're not going to read the book, and therefore you're going to lose points in the exam because some of the questions are straight out of the book. Okay? So you should read the book. Some of the book is online in a new version. You should use the online version. Dan Jaraski encourages that. Okay? You should already be invited to Piazza. If you're not and you believe you're registered in the class, you should let me or David or the TAs know, because we want to fix that. Canvas will be used for assignments, submission and grades. Okay. I don't believe there's anybody on the wait list. If you're on the wait list, we want to let you in, and we will do that this week. If we can't get you in, it's probably because you've got too many units and there's something else blocking it. We don't have control, but if you're trying to play this game of like, I want to go in this class or this class, but if I drop one of them, I won't get in the other. You will get into this class. You can see that there's empty seats here. We have no problem getting into this class. Okay? there will be readings, there will be homeworks that you have to do, and remember there's a project, and next Tuesday I'm going to spend the whole lecture talking about what the project is. The project is in teams. You will be in teams of 4. You really will be in teams of 4, not 1, not 20, because there's a lot of work and we want to even things out and we want to make it easy for us to grade. Okay? It's going to be building question answer systems, but unlike the things that are online, you have to do all the work yourself. Okay? You're not just allowed to connect it to Google and get Google to do your homework for you. Okay? But we'll talk about that next week. Over the years, we've encouraged different programming languages for people to do the work in. We now don't do that. You can choose any language you want for doing the programming, but everybody uses Python apart from 6 of you who use Java. And that's okay. We're not going to judge you for using Java in any way whatsoever. You can choose whatever programming language you want, but often we will give you things in Python. You are not allowed to use other people's code that you find out there, apart from in the project where you'll be using subsystems that will be coming from elsewhere. You are expected to write your own code because we're trying to educate you, we're trying to give you the experience. We know that if you search out there, you'll find people's answers on GitHub from previous versions of this course, okay? Don't use that, okay? One, it's cheating, and even if you give a citation that's not cheating, it means that you didn't learn anything if you're using somebody else's code. I know in real life you're going to look for other people's code, and that's fine, but in this class, we're teaching you to do things, so please write your own code. If you are using anything external that isn't relevant to the piece of work that we're asking you to do, make sure you give a citation for it, because that would be polite. If somebody's going to use something that you did, you'd like to get the citation for it too. So make sure that you do that. Okay? Okay. That's it for this lecture. If there's any questions, either come down to the front and ask them.